A fast-moving object the size of Manhattan is hurtling towards our solar system, and it will make its closest pass to Earth.
In October 2025, the interstellar traveler, known as 3I Atlas, reaches the end of its journey through our skies. As it slips into the sun's glare, telescopes are catching a strange final transmission. It's not a message anyone expected, not a voice, not a signal we can decode outright, but something stranger, fragments scattered in light and shadow. Soon, Atlas will disappear into silence, leaving an emerald signal in the eclipse. September 7th, 2025. A total lunar eclipse darkened the sky, turning the moon a deep, rusty red. Millions of people watched that familiar spectacle, but those following 3I Atlas noticed something far stranger. Through telescopes and long-exposure photos, Atlas revealed a faint green glow. At first glance, it was subtle, but against the backdrop of the blood-red moon, the color stood out sharply, emerald and crimson side by side in the same sky. The effect was eerie, almost theatrical, as if the interstellar visitor had chosen the eclipse as its stage. Comets can glow green, but not often. When they do, the cause is usually diatomic carbon, simple molecules breaking apart when struck by sunlight. Yet with Atlas, the chemistry wasn't straightforward. Early spectral data didn't match neatly with the expected carbon signature. That raised the possibility of something different, perhaps another molecule, perhaps a mix of compounds not commonly seen in comets from our solar system. That's what made the sight so significant. A routine comet would have followed the rules we know. Atlas didn't. Instead, it flashed a signal that was part science, part mystery. If its glow really came from a different chemical balance, then Atlas was carrying material shaped under conditions foreign to our sun. The timing only amplified the effect. On the same night, Earth's shadow painted the moon red. An object older than Earth itself displayed its own color in green. It was the first clear anomaly, the opening fragment of the transmission we're still decoding. This wasn't just a comet glowing, it was a comet speaking in the only language it had, light, and that emerald line was the first word. When dust refused to behave. If the green glow under the eclipse was the first anomaly, the second came when scientists studied how Atlas scattered light. Comets usually follow a predictable script here. Their dust reflects sunlight in certain ways, creating patterns we've seen hundreds of times. But Atlas didn't play along. Polarimetric measurements, basically studies of how light is polarized when it bounces off dust, showed something no one expected. Atlas displayed an unusually deep and narrow negative polarization branch. At a small angle to the sun, the numbers plunged to about minus 2.7%. Then, at around 17 degrees, the signal flipped again. For non-specialists, that might sound like technical noise, but in comet science, this is huge. No known comet or asteroid in the solar system has shown this exact behavior. Normally, the light curve is smooth, predictable. Atlas's was sharp, exaggerated, almost like a spike in a signal. What could cause it? One idea is that Atlas's dust grains are built differently, maybe larger, maybe structured in a way that bends light in unusual patterns. Another possibility is that the dust is coated in ices or compounds we rarely see near our sun. Whatever the case, the result was the same: light that looked distorted, carrying a signature we couldn't immediately explain. That's why some astronomers described it as if the comet's dust was talking back. The sunlight didn't just bounce off Atlas, it came back twisted, carrying information. To some, it looked almost like a coded fragment inside the transmission. This was the second clear anomaly. First, the unexpected color. Now dust scattering that didn't follow the rule. Atlas wasn't simply glowing and shedding material like every other comet. It was showing us, line by line, that its transmission would be harder to read than anyone thought. Water where the sun cannot reach. If Atlas had stopped at strange colors and dust, it would already be remarkable. But another anomaly arrived when astronomers turned ultraviolet eyes on it. Using NASA's Swift Observatory, they detected something comets shouldn't show at that distance: water activity. Normally, comets begin releasing water when they're much closer to the sun, within 2 astronomical units or so, where the heat is strong enough to melt ice into vapor. Atlas, however, was still out at about 3.5 astronomical units, farther than Mars, where the solar warmth is weak. And yet, the data revealed clear signs of hydroxyl OH molecules, the unmistakable proxy for water. The numbers were hard to ignore. Atlas was producing water at a rate of roughly 1.35 times 10 to the 27th molecules per second, about 40 kilograms of water every second. At that distance, a typical comet would still be asleep, frozen solid. But Atlas was already awake, venting like something carrying its own internal heat, or a chemistry primed to break the rule. What made it even stranger was how steady the release appeared. It wasn't a sudden flare-up or a random spike. The activity was consistent, as if Atlas had a hidden reservoir of water ready to bleed off long before solar heating should have triggered it. That's not how our comets behave. In our system, water waits until the sun calls it out. Atlas seemed to act on its own schedule. This was the third fragment of its transmission. First, the green glow. Then, dust scattering like a coded signal. Now, water appearing in the cold outer reaches, where no water should yet flow. Atlas was telling us something through its chemistry. Whatever star system it was born in, the rules of formation weren't the same as ours. In one quiet ultraviolet observation, we got proof that Atlas carried the fingerprints of a different sun, and that fingerprint was written in vapor, the tail that pointed the wrong way. Every comet has a tail, and every tail has a rule. It points away from the sun. Radiation pressure and the solar wind push dust and gas outward, carving that familiar streak across the sky. It's one of the simplest, most predictable parts of comet science, but Atlas chose not to follow it. When the Hubble Space Telescope turned its eye toward the visitor, astronomers noticed something unusual. Along with the main tail stretching outward as expected, Atlas displayed a sunward extension of brightness, an anti-tail. Instead of material blowing away, some part of its coma seemed to stretch toward the sun. At first, it looked like an imaging trick, but repeated exposures confirmed it. There was real asymmetry in the glow. The effect was faint yet striking. Where comets are supposed to trail neatly like streamers in the solar wind, Atlas looked messy, almost defiant. What could cause such a thing? One idea is that large fragments of ice and dust ejected from the nucleus weren't pushed as easily by radiation pressure and instead lingered in odd configurations, creating the illusion of a sun-pointing streak. Another suggestion is that Atlas's dust grains are unusually reflective or structured, bending the light in ways our models don't normally account for. Whatever the reason, the image itself was unforgettable. A comet breaking the most basic rule of comet behavior. A tail that didn't just point away from the fire, but reached toward it. Atlas wasn't simply passing through our solar system. It was rewriting the visuals of what a comet can look like, and the anti-tail was the boldest reminder yet. This object wasn't here to play by our sun's rule. A heartbeat written in red. Most comets flicker with activity, but Atlas began to show something more rhythmic, almost like a pulse. As astronomers tracked it through July and August 2025, careful photometry revealed a rotation period of about 16.16 hours. That's not extraordinary on its own, but what stood out was how the comet's brightness and color shifted with that cycle, like a repeating beat in its signal. The dust output, for instance, wasn't dramatic. Calculations put the rate at only 0.3 to 4.2 kilograms per second, modest by comet standards. But it wasn't steady either. Some phases of rotation released more, some less, creating a pattern that suggested the nucleus wasn't uniform. Atlas wasn't venting evenly. It was patchy, as if one side carried reservoirs that the other side lacked. Then there was the color. Over the course of the summer, Atlas's hue gradually reddened. To the eye, it was still faint, but instruments caught the change. Comets from our system sometimes redden as dust builds or surface material alters under sunlight, but Atlas's rate was faster, sharper. That raised questions. Was its dust coated in compounds that darkened more quickly? Was it shedding grains that reflected light differently as it spun? Put together, the details felt less like random noise and more like a pulse. 16 hours on, 16 hours off, a spin written in flickers of light, dust, and color. To some observers, It resembled a heartbeat, faint but persistent. In the ongoing transmission, this was line 4. Not just color shifts, not just strange dust, but a rhythm. Atlas was revealing its body through its spin, showing us scars and patches across its surface without ever needing a close-up. It didn't look alive, of course, but the cadence of its rotation and the deepening red made it feel less like a cold lump of ice and more like a signal repeating through the void, a pulse from another star, a weight too great to ignore. From the start, Atlas looked big, but big in astronomy can mean anything, from a city-sized chunk of rock to something large enough to swallow a mountain range. Pinning down its true scale became one of the most urgent questions, and the answers kept creeping upward. Early estimates, based on ground-based images, suggested a nucleus a few hundred meters across, manageable, large, but nothing we hadn't seen before. Then Hubble data came in and shattered that comfort zone. Depending on how bright or dark the surface actually was, Atlas could measure anywhere from 320 meters to nearly 5.6 kilometers across. That's a margin wide enough to fit an entire city on the small end, or a sprawling county on the large end. The weight was equally unsettling. Calculations suggested a mass running into the tens of billions of tons. That's not a comet you brush off. That's a celestial freight train passing through our neighborhood. To put it in perspective, if something of that size ever did wander onto a collision course, the energy released would dwarf anything humanity has ever faced. Even the asteroid that ended the dinosaurs was estimated at about 10 kilometers across. Atlas isn't in that league, but it's alarmingly close. Thankfully, its orbit offers no threat. Atlas will never come near Earth, but that's beside the point. The real message from this line of the transmission is about scale. Our first interstellar visitor, Oumuamua, was tiny and elusive. The second, Borisov, was bigger but ordinary in behavior. Atlas is the heavyweight. It's proof that not all interstellar objects are harmless shards. Some are vast, massive bodies that slip through the solar system without warning. The weight of Atlas isn't just physical, it's psychological. Its size forces us to admit that we don't know how many giants like this are out there, moving between the stars. And if this one had been aimed differently, we'd be telling a very different story. The chemistry of another sun. Light doesn't just show us how bright an object is, it shows us what it's made of. When telescopes split Atlas's light into spectra, the results were unlike anything we usually see in comets that were born under our sun. Most solar system comets carry water as their primary signature. H2O dominates their comas, mixed with smaller amounts of carbon dioxide and carbon monoxide. But Atlas flipped that balance upside down. Observations with the James Webb Space Telescope and later the SPHERE-X mission showed a coma dominated by carbon dioxide with a CO2 to H2O ratio nearly 8:1. That is extreme. In practical terms, it means Atlas's atmosphere is built from a chemistry rarely seen here. In fact, among hundreds of comets studied, almost none show this level of CO2 dominance. Water, yes. Dust, yes. But a carbon dioxide cloak this thick, that's a clue that Atlas formed in an environment very different from the early solar system. Wherever Atlas was born, the rules of planet and comet formation weren't the same as ours. Maybe it came from a disk of material rich in CO2 ice, orbiting a cooler or more carbon-heavy star. Maybe it was pushed outward early in its life, where CO2 could freeze easily, but water couldn't. Either way, it carried its birthplace's chemistry with it, and now, millions of years later, we're reading that fingerprint as part of its final transmission. Every comet tells a story about the place it formed. Atlas's story is that its home system followed a recipe very different from ours, and with just one strange ratio, it reminded us the universe doesn't build by one pattern. Older than our world. The farther astronomers traced Atlas's path back, the stranger the story became. This wasn't just a comet from another star. Its orbit and chemistry hinted at an object born in a time and place far older than Earth itself. Models of its motion through the galaxy suggest Atlas didn't come from the thin, orderly disk of stars like our sun. Instead, its speed and trajectory match better with the galactic thick disk, a population of stars that formed more than 7 billion years ago. That's at least 2 billion years before Earth even existed. Think about what that means. When Atlas was forming, Earth wasn't a planet. The sun wasn't even born. Dinosaur, humans, everything we know, all still billions of years in the future. And yet somehow, this chunk of ice and dust survived, preserved in the deep freeze of interstellar space, only to wander into our solar system now. Its age also helps explain its chemistry. A CO2-rich body makes sense if it formed in an early, colder environment, one where carbon dioxide could freeze more easily than water. The dust grains could carry structures shaped in a very different cosmic neighborhood, hardened over eons before being kicked loose by some gravitational encounter. Atlas is, in effect, a fossil of another star system, not a fossil in rock, but in chemistry, age, and structure. It is older than Earth's oceans, older than the continents, older than life itself here. And yet it drifts past us today, giving us only a few months to catch what signals we can. The red planet as witness. By early October 2025, Earth's view of Atlas was already narrowing. As the comet slid closer to the sun, glare and geometry began to work against us. But one world stood in the perfect position to watch it up close. Mars. Between October 1st and 7th, Atlas passed within about 29 million kilometers of Mars. Close in astronomical terms, a chance encounter that put the red planet right on the visitor's path. And circling Mars were some of the most capable observatories we have: NASA's Mars Reconnaissance Orbiter, ESA's Mars Express, and the ExoMars Trace Gas Orbiter. For once, these spacecraft weren't just studying Mars, they were repurposed as deep space watchers, turning their instruments outward to catch the interstellar comet. From Mars's vantage point, Atlas could be observed without the interference Earth was starting to suffer. No solar glare, no awkward angles, just a clean line of sight to its coma, its tail, and its strange behavior. The opportunity was unique. Instead of one planet watching, two planets were now part of the transmission. Earth could provide ground-based spectra and images. Mars could give us a second angle, something never possible with Oumuamua or Borisov. That meant better chances of sampling Atlas's dust activity, coma chemistry, and tail geometry from a perspective Earth couldn't match. Think about the poetry of it. Our neighboring planet, lifeless and red, serving as witness to an object older than both our worlds. Instruments built to map Martian valleys were suddenly tracking a green-tinged, CO2-rich comet from another star system. This was the 9th fragment of the transmission. It wasn't just data from telescopes on Earth, it was a chorus, coming from multiple worlds at once. The red planet had become our ally in decoding the message, and in the short window before Atlas slipped behind the sun, Mars gave us the extra set of eyes we desperately needed. Into the fire, into silence. By the end of October 2025, Atlas reaches the point every comet must face: perihelion. Its closest approach to the Sun will bring it within about 1.36 astronomical units, just outside Earth's orbit. For Atlas, a body that has traveled for billions of years across interstellar space, this is the trial by fire. For us, it is the moment of silence. Around October 29th and 30th, Atlas moves into solar conjunction, hidden in the sun's glare from Earth's perspective. Our ground-based telescopes will be blind. Even the largest observatories won't be able to pierce the brightness. That means the only watchers left are spacecraft already in space, orbiters around Mars and Jupiter, instruments that can look sunward without our atmosphere blocking the view. This is the closing of the transmission. For months, Atlas has spoken in fragments, a green signal under the eclipse, dust bending light in ways we've never seen, water venting where no comet should, a tail pointing the wrong way, a pulse in red, a weight too great to ignore, chemistry from another star, and an age older than our own planet. Now, as it dives past the sun, the last fragments will stream in, and then it will be gone. We don't know what will happen next. Atlas might survive the encounter, swinging back out into the dark, or it could fragment, breaking apart under solar heat, scattering its story in pieces too faint to follow. Either way, our chance to study it will end in silence. And maybe that's the point. The transmission was never endless. It was always a brief signal, a passing message from another world, carried on light and dust. Atlas came into our skies not to stay, but to remind us that the galaxy is full of wanderers, and that some of them are vast, strange, and older than we can imagine. The line is complete. The signal ends here. Let us know your thoughts in the comments down below. Don't forget to like and subscribe for more space content.